Hope all of us are doing great. This is Honest Sciences and Mathematics TV channel. Now, I'd like to welcome our members to our discussion for today. I'm going to look at a short summary of basically the aluminum halides, and this is going to give us one of the unique characteristics of especially the chloride of aluminium. And this, of course, we have discussed it in one of our videos when we were contrasting it with one of the, of course, compounds of boron, and that was boron hydrate, which we had given in this specific form. Now, in this case, for aluminium, we're going to see that the aluminium is going to form what we refer to as a dimer, and of course, this is going to be appearing in the form of this analogous structure, which we had given that basically had what we referred to as a 3-center to an electron bond. And for this case, we're going to be drawing this specific structure of aluminium in order for us to contrast it from these others. But of essence for us is to understand the concept of aluminium halides. And in this case, halides, of course, I said that these are going to be compounds of halogens. Of course, whereby we're going to have this specific metal being given as aluminium, and then the rest, of course, are going to be halides given in that specific form. So aluminium halides are going to be considerable, having some of the aluminium halides are going to be having considerable ionic character. For instance, we're going to see that the aluminium fluoride, which is going to be given as such, is going to have a melting point of around 1,000. Of course, this approximately 1,040 degrees Celsius, and of course that's going to be a very high temperature. Now in this particular case, when we are going to melt this, so this is going to be having particularly what we refer to as ionic character. So we talked about the concept of ionic bonds, covalent bonds, in that specific case, hydrogen bonds. So in this case, it's going to have an ionic character. And of course, we're going to see that it's going to be having a considerably high melting point given that specific range. Now, when this specific, of course, compound is going to be in a molten state, it's going to be a good conductor of electricity, which of course we have given this specific reason for being ionic. Now, in this case, in contrast with other halides which we are going to come across, for instance, which are going to be given in terms of this compound which we have mentioned. So we're going to have aluminium forming molecular species in contrast with this specific ionic character. Some of the halides of especially chlorine, bromine, and iodine. So we're going to see that this X is going to be chlorine, bromine, and iodine. These are going to form molecular species, which we are going to give you an example in terms of the sp3 hybridized bonding for the particular aluminium, which we're going to see being given in this specific case. So we're going to draw a structure which is going to assist us in appreciating this specific compound, which we had said, of course, we are going to contrast it with some of the compounds of especially boron, which we had seen in our last discussion. So this structure is going to appear in this specific form, whereby we're going to have these central atoms of aluminium being bonded to the chlorides given as such. So that's going to form that specific structure, which is sp3 hybridized bonding. So the two aluminium atoms which are going to be appearing at this specific point are going to be sp3 hybridized atoms. So in this case, I've talked about the concept of hybridization of atomic orbitals. I'm going to put a link in the description box so that we can be able to check out and understand that particular concept. Now, most of the halides are going to be very reactive, and they're going to form what we call Lewis acids. So the halides of aluminium are going to be very reactive compounds, and they're going to form what we refer to as Lewis acids. So in this case, we're going to see them in some of our applications that we're going to come across, in some of our videos, perhaps, which is going to precede this specific video. Now, I'd like to request our members to be checking our description boxes for various links of other similar videos and also ring that notification bell and subscribe to our channel so that you get more updates on our various uploads on similar topics. So that is it for now, guys. Bye. God bless you. Catch us in our next video.